Hello, thanks for checking out this video. In today's video, we'll be looking at LeetCode problem number 1588, the sum of all odd length subarrays. The problem description says, given an array of positive integers, we want to calculate the sum of all possible odd length subarrays. We're told that a subarray is a contiguous subsequence of the array, and we want to return the sum of all odd length subarrays. So here's the first example that they've given us. We have an array of length 5 with the numbers 1, 4, 2, 5, and 3. And just to clarify real quick what a subarray is, a subarray means we're going to start at some number, maybe I start at 1, and we're going to move in the right direction and end at some other number, maybe I'll end at 2 here. The subarray here would be 1, 4, 2. We have to include all numbers from 1 to 2. And you just choose some number and then go right and end at some other number. I could also, if I have wanted to, start and end at 5. This would produce the subarray just 5. It's different from a subsequence because in a subsequence you can start and end at some value, but you don't need to include every number in between. I like to just be very sure that I know that we're dealing with a subarray or a subsequence because there's been a few times where I thought it was a subsequence that I was looking at, and I made the problem more difficult than it needed to be. But in this problem, we are looking at subarrays. Now I've gone ahead and written out all the possible subarrays with their lengths. So in this purple column on the left, I have all of the subarrays of length 1. There's 1, 4, 2, 5, and 3. And then likewise, in the second column, I have all the subarrays of length 2. And then there's the subarrays of length 3, 4, and 5. But we're really only interested in the odd length subarrays. So the odd length subarrays are 1, 3, and 5. We don't really care about 2 and 4 because those subarrays are all even length. So what I'm going to go ahead and do is look at this first number 1 and look at, for every odd subarray, how many times does it appear? It appears once in the purple, once in the blue for length 3, and then 1 in length 5. So it appears 3 total times. How many times does 4 appear in an odd length subarray? It appears once on the left. It will appear twice actually for a subarray of length 3, and then it will appear once for a subarray of length 5. So it actually appears 4 times. Now we'll look at how many times does 2 appear. It appears once for a subarray of length 1. For a subarray of length 3, I actually have these 3 here. So I'm up to 4 already. And then I have one more here for length 5. So this actually appears 5 times. And then if I look at how many times 5 appears, it appears once, 2, 3, 4 times. And then how many times does 3 appear? 1, 2, 3. It appears 3 times. Now I want to go ahead and multiply these together. If I do that, I'll get 3, 16, 10, 20, and 9. And if I add up these 5 numbers together, I will get 58, which is the expected answer. Now look what we did there. We looked at how many times each number appears in an odd length subarray, and then however many times they appear in that length subarray, we just multiply it by that number, and that's how we get the answer. The hard part of this problem really becomes calculating how many times each number appears in these odd length subarrays. So let's try to figure out how that can happen. If I take a step back and I look at, for whatever number is at index 0, I'm going to write the indices above here real quick. If I look at, for index 0, how many subarrays total, not just odd length subarrays, but subarrays total index 0 appears at, I can calculate that by taking the subarrays that start with that, and then multiply it by the subarrays that end with that. So here's what that means. Let's say, for example, you have city A, you have city B, and you have city C. There are 2 paths from A to B, and there's 3 paths from B to C. If I asked you, how many paths total, unique paths, are there from A to C that go through B? Here's how you could do it. You could just count them. You could say, well, there's 1 if I go from the top to the top, that's 1. I could go top to the middle, that's 2. I could go the top to the bottom, that's 3. I could also go from the bottom to the top, that's 4. I could go from the bottom to the middle, that's 5. Or I could go from the bottom to the bottom, and that's 6. Another way to calculate that is there was 2 choices from the left-hand side and 3 on the right. There were 2 choices that end at city B and 3 choices that start at city B. So it's kind of a similar process here. We're going to look at, for each index, how many subarrays start at that index and how many subarrays end at that index. And here's how we can do that. So for index 0, how many subarrays start with 0? I look at how many subarrays start with 0, index 0. There are 5. There's the one of just the number itself, 0. I could go 0 to 1, 0, 1, 2, 0, 1, 2, 3, and 0, 1, 2, 3, 4. So there's 5. And how many end at index 0? There's just 1. There's the index of just itself. When I is 1, if I'm looking at index 1, how many subarrays start with 1? The answer is 4. There's 1, 2, 1, 2, 3, 1, 2, 3, 4. And that's it. If I look at how many end, I have 2 choices. It could be 0, 1, or just 1. And you might be able to see the pattern that in general, the number of subarrays that start from whatever index you're looking at is n minus I, where n is the length of the array and I is whatever index you're looking at. So if you look at the case when I was 0, if we take 5 minus 0, we get 5. Or in the case when I is 1, 5 minus 1 is 4. If we look at how many subarrays end with that value, it's I plus 1. But if we look at this, when I is 0, we have 1 choice. When I is 1, we have 2 choices, and that just scales linearly like that. And if we multiply these together, we get the total number of subarrays, not the odd length, but the total number. Then the next problem becomes, well, if I know the total number of subarrays, how can I calculate the odd? Well, if I know the total, and I cut that in half, just take the total number and divide by 2, that'll almost give me the answer. It actually sometimes will give me the answer, because I know that half of them will be even, and half of them will be odd. However, in the case where a number appears in an odd number of subarrays, there will actually be an extra odd one. So here's what that means. Let me scroll up a little bit. We saw here that for the number 1 at index 0, it appeared in 3 odd subarrays, but only 2 even subarrays. The total number of subarrays it appeared in was 5, so it appeared in 5 total. When we cut that in half, we get 2 for rounding down. So that's how many even subarrays it appears in. If n is odd, the number of subarrays it appears in is odd, then I have to add one more to take into consideration that extra odd subarray it appears in. So if I add 1 to this, it would be 3. 1, index 0, the number 1 appears in 3 odd subarrays. It appears in 5 total. It appears in 2 even and 3 odd. So you have to pay attention now to if the total number of subarrays is odd or even. I'm going to do one more example now with our original input using our formula we're using, where we look at how many subarrays start and end at a particular index, and then how many total subarrays include that, and then the odd, just so you can see how the numbers start to play in. So if I look at index 0 again, I think we already looked at this. There are 5 subarrays that start with index 0. There's 1 that ends with it for a total of 5. Looking at index 1, there are 4 that start with it. I'm getting 4 by plugging 1 into our formula of 5 minus I. The end would just be 2 for a total of 8. For index 2, I would get 3 subarrays that start, 3 subarrays that end, and 9 total subarrays that include the value 2. For index 3, I would have 5 minus 3, which is 2, that start with it, and I would have 4 that end with it for a total of 8 subarrays, including index 3. And for index 4, I would get 1 subarray that starts with it, 5 that end with it, for a total of 5. And to calculate how many odd subarrays, I divide by 2, and if my total is odd, I add 1. If it's even, I leave it. So 5 divided by 2 in Java would be 2, but because 5 was odd, I add 1 for 3. 8 divided by 2 is 4, and that's even, so I can leave it. 9 divided by 2 would also be 4, but because 9 was odd, I add 1 to get 5. I already did 8, and I knew that was 4, and I already did 5, and I knew that was 3. And if you look at these numbers down here, they exactly match what was up here when we brute forced it and just listed all of the subarrays. So this is a very fast way to look at how many times a particular index appears in all odd length subarrays. Once we know this, we just multiply this odd value, however many odd subarrays contain the value, by the value itself, and keep track of that sum. Now let's take a look at the code for how this can work. The first thing I want to do for the code is create a variable to hold on to the sum, and that at the end here I'll make sure to return that. I also want to have a variable to keep track of the length of the array. This is going to make the code look cleaner later on. Now what I want to do is iterate through every index of this array. And I want to keep track of how many end here and start here. So remember the formula for how many subarrays end at this index? It was I plus 1. And then how many start here is n minus I. For the total, it's just the multiplication of the start and the end. And then finally, the odd are going to be the total divided by 2. And then there's a quick check I got to do, because if the total was odd, then I have to add 1 to the odd subarrays that this value appears in. Finally, I can add to my result the multiplication of how many odd subarrays this value is in times the value itself. And if I go ahead and do that, let's see what the answer gives us here. 58, just like we expected. And if I submit, then we get a successful run. If we look at the runtime complexity real quick for time and space. If we look at just time first here, there is one for loop which will run n times, and all these operations inside of the for loop are constant time, meaning this is O of n time, and space complexity, we're just using variables, we don't declare any extra memory. So the space is constant space. Thank you for watching the video. If you have any questions, please comment, and if you have any video suggestions, please let me know and I'd be happy to make one. Thank you.